Okay, so in this video, we're just going to do other problems that we haven't necessarily covered in other videos. So it's just different variations of problems that we've already done. So feel free to skip if you already know how to do something, but some of these I think are pretty tricky. Okay, so let's see. This first problem, let's pretend you want to go bowling and your shoes cost $4 and it costs $3 per game to bowl. Okay, so the first thing we want to do is write a recursive formula. So just a reminder, recursive, you start with a sub 0. So if you want to go bowling, you have to pay for your $4 shoes. So our starting value is going to be 4. Then we have a sub n equals a sub n minus 1. And then per game, it's $3. So we are going to add $3 per game. And then to write a function rule, it's linear because you're adding. So we're going to have y equals we are adding 3 every time, so that's 3x and then plus 4. And then, so let's say this is 1a. 1b would be how much would it cost to do 20 games? So if I take 20 and I plug it in here, so let me back up. So if let's say I go to the bowling alley and I don't want to bowl at all, or I buy my shoes and then I decide I don't want to bowl at all. So if I draw this little table, these are my x values, here are my y values. So if my x value is 0, so that means I'm bowling 0 games. So if I plug a 0 into this, I still have to pay $4. If I want to bowl 1 game, it's going to cost, if I plug a 1 in here, that's going to give me $7. So now if I want to bowl 20 games, all I have to do is plug 20 in for x, and you get 20 times 3 is 60, so $64. So I'm not sure who would be playing 20 games, but if you do, it'd be $64. Okay, so that one was on the easier side. So let's pretend that you have a salary, or you got a new job and you have a salary of $50,000. Every year, you get a 4% raise. So you started a new job. The first year you get paid $50,000. The second year you'll get a 4% raise from this. So the first thing I want us to do is write a function for this. So we'll have y equals your starting value, so 50,000. So now when you multiply, you're not multiplying by 4. You need to write this as a percent, but you don't only want 4% of this, you want 4% more. So that's when you do the 1.04. So this would be a 4% raise to the power of x. So what is the salary for the second year? So your salary for the second year, so this is where it gets a little bit confusing. So if I were to plug in a 0 here, 1.04 to the power of 0 is 1. $50,000 times 1 is 50,000. So almost for all of these problems, I'm just going to make this short little table because I think it helps to understand a little bit more. So if you plug in 0, you get 50,000. Oh boy. And that was my first year. So in my first year, I plugged in 0. So in my second year, I'm going to plug in 1. So if I plug in 1 here, you end up taking 50,000 times 1.04, and you get $52,000. So don't automatically just go ahead and plug in a 2 here because you won't be right. So let's see, second year, you get $52,000. Okay, so then what about the 10th year? So to get to my 10th year, notice how my second year was 1, so it's just 1 less. So to get my 10th year, here I have 9. So I plug 9 into here, and if you put that into your calculator, you get $71,165.59. Okay, and then the next question is, okay, what's your total earnings? Earnings after 10 years. So after 10 years, so are we adding the same number every time or are we multiplying? Well, this is exponential, so we know we're multiplying. So that means it's geometric. So the formula we're going to use is a times r to the n minus 1 over r minus 1. So our first value was $50,000. Our r is what we're multiplying by, so we're multiplying by 1.04. N is the number of values, and that's going to be 10 because our first year is year 1, our second year is year 2, so you don't have to subtract or add anything to the number 10. Then you have minus 1 divided by 1.04 minus 1. If you type that into your calculator, you get $600,305.36. Okay, the next problem. Okay, let's see. Okay, let's look at this one. So this says evaluate each series. So remember, a series just means it's a sequence and you're adding all of the numbers together. So here we have 5 to 9, 9 to 13. So it looks like we're adding 4 every time, all the way up to 133. So we're adding, so that means it's arithmetic. So that means we're going to take our first number plus our last number times your number of numbers divided by 2. Okay, so our first number is 5. Our last number is given to us. That's 33. Okay, but now we don't know how many numbers we have. So in order to figure out n, we need to write our function. So we'll have y equals, we're going up by 4, so that's 4x plus 5. And then we know our last number is 133. So before I get into that, I'm going to make my little table. X, Y. Okay, so if I plug in a 0 to this, I get 5, which is my first term. If I plug in a 1, I get 9, which is my second term. So when I plug this 133 is a y value, so that would go here. So I need to find my x value. So if I plug in 133 equals 4x plus 5, I'm going to subtract 5 from both sides and divide by 4. So that gives you 32. So my x value is 32. So that does not mean you have 32 terms. So if I plugged in 0, I got my first term. If I plugged in 1, I got my second term. So if I plug in 32, that's actually my 33rd term. Third. So these are going up by 1. So that really means my n is 33. So if you plug that into your calculator, 5 plus, oops, not 33, 133. 5 plus 133 times 33 divided by 2 gives you 2,277. So another one we can do 5, 15, 45, all the way to 10,935. Okay, so here it looks like we are multiplying by 3. So if you're multiplying, that is geometric. So geometric, our formula is a times r to the n minus 1 over r minus 1. So a is our first term, so that's a 5. Our multiplier is r, and then we're multiplying by 3. So now we still don't know how many numbers we have, so I'm going to leave that blank. All over 3 minus 1. Okay, so we're going to do the same thing that we did up here, except for now, since you're multiplying, it's going to be exponential. So we have y equals, our starting value is 5, our multiplier is 3 to the power of x, and we know that our y value is 10,935. So we have 10,935 equals 5 times 3 to the power of x. So divide both sides by 5, and we get 2,187 equals 3 to the power of x. So when you are trying to solve for an exponent, you need to write it in log form. So to write this in log form, we have log base 3 of, log base 3 of 2,187 equals x. So if you do not have an Inspire, you cannot plug this into your calculator. So you have to write it in change of base form. So log of 2,187 divided by log base 3, and that gives you log of 2187 divided by log of 3 gives you 7. Okay, so we have x equals 7. So I'm going to make that little table. X, we have y. So if I plug in 0 to this equation right here, 3 to the power of 0 is 1. 5 times 1 is 5, which is our first term. So you should start seeing patterns. When we were over here, we plugged in 7, and you get this 10,935. Oops, 5. So if 0 was our first term, this went up by 1. 7 is going to be our 8th term. So instead of an n, we can actually put in an 8. So you type that into your calculator. You get 16,400. So this was the gist of all the other problems that we haven't done yet.